Okay, so in this section we're going to talk about section 4.3 is about what's something called factoring. We have basically three main goals. Number one is to answer the question, what does it mean to factor something? Two is, what does it mean to solve an equation by factoring? So what is factoring? How do you solve an equation by factoring? And then how do you factor? There are five main types of factorings I want to show you. One, which is called factoring out the greatest common factor, the GCF. Factoring what's called a trinomial, where the leading coefficient, I'll explain what that means, does equal 1, and then what do you do when it doesn't equal 1. Factoring something called a difference of squares, and then finally a method called factor by grouping. So first question is, what is factoring? And factoring is basically, it's kind of like the reverse of multiplying. So for example, if I said, what is 5 times 3, you would say it's 15. On the other hand, if I said take 15 and factor it, that means go backwards. Tell me, what did I multiply to get 15? And the answer is 5 times 3. It's the same idea with polynomials, not just with numbers, with things that have x's and variables in them. So for example, if I had this equation right here, x plus 3 times x plus 4, we could multiply that using the acronym FOIL, which means first, outside, inside, last. So the first terms in each parentheses would be x times x, and that equals x squared. The outside terms right here would be x times 4, which is 4x. Okay, then the inside terms would be the 3 and the x. Let me just use a different color for that. 3 times x would be 3x. And then finally the last terms would be 3 times 4, which is 12. So now if we combine these, we have x squared, 4x plus 3x is 7x, and we have the plus 12. So here's what it would mean to factor this. Factoring means start with this and go backwards. Tell us, what did you multiply? And if you think about it, here's how you can factor this. You can ask yourself, how did I get the number 12? And I got the number 12 by doing 3 times 4. How did I get the number 7? I got it by doing 3 plus 4. So when you're factoring, what you want to do is you want to say what numbers multiply to that and what numbers add to this. There's a lot of numbers that multiply to 12. There's 1 times 12, 2 times 6, and 3 times 4. But out of those numbers, there's only 2 of them, only these two, that both multiply to 12 and add to 7. So that is the answer to the first question. What does it mean to factor? It means to start with this end result right here and to go backwards to figure out what did I multiply to get that. Second question, what does it mean to solve an equation by factoring? So here's two different questions. We'll call this question 1, and that question says factor. This question 2 says solve by factoring. Very similar questions, but there's one difference. Okay, they both have x squared plus 7x plus 12. On the left side, they ask you to factor it, and we just did that. If you factor this, what multiplies to 12 and adds to 7? It would x plus 3x plus 4. You stop right there. You're done with number 1. This one right here has the same first step, x plus 4 times x plus 3. But to solve something means that your final answer should say x equals something. X equals a number. How do you solve this? Well, we know that this has to equal 0. So we need to say what number plugged in for x right here would make that parenthesis 0. And the answer is negative 4. Negative 4 plus 4 is 0. And then 0 times, it doesn't matter what that second parenthesis is in, 0 times anything is going to equal 0. Second parenthesis, what number plugged in here would make this whole thing 0, and that's negative 3. And you can test. You can plug in either negative 4 for x right there, or you can plug in negative 3 for x, and in both cases you get 0. So that's what it means to solve. Solving means x equals what number as your final answer. Alright, now we're going to work through some of these problems. So this one says write an equation in standard form. And a quadratic equation in standard form looks like this. ax squared plus bx plus c, and it's always equal to 0. Write an equation in standard form that has these two numbers as the zeros. So here's how you can think about it. In that example that we just did, we factored it and we wound up with this right here. This is the example on the previous page, and we had negative 4 and negative 3 as our answers. This is telling us start with these zeros and go backwards until we have these two equations. So the way that you can do that for negative 1/3 and 6 is, let's just make a blank parentheses right here. And we want to plug in, let's start with 6. We want to plug in 6 right here and do something to 6 so that we will wind up with 0. And the only thing you can do to 6 to get 0 is you could subtract 6 from it. 6 minus 6 would be 0. So the pattern is you always end up having a parentheses with x minus the root, or x minus is 0. Root is another name for 0 or solution. Okay, if we follow that same pattern for negative 1/3, if you plug in negative 1/3 right here, negative 1/3 plus 1/3 would be 0. Okay, that's another way of saying x minus negative 1/3, because remember, it's always x minus the root. Okay, this is almost finished now, but we need to write it in standard form, which means it has to look like this, and right now it doesn't. So the way you could do that is by foiling it. Before we foil it, though, it would be nice if we could get rid of this fraction right here. So let's multiply by 3, and we'll distribute the 3 to these two. Why did I choose to multiply by 3? Because that has a denominator of 3, so it will cancel out. By the way, we're only multiplying the 3 by this first parentheses, not by the second one. So the second one stays the same. When you distribute 3 to x, you get 3x. When you distribute 3 to 1/3, you get 1. So these are equivalent right now, and now we should FOIL this out. So the first terms, x times 3x is 3x squared. The outside terms, x times 1 would be just 1x, or x. The inside terms, negative 6 times 3x is negative 18x. And finally, the last terms are going to be negative 6 times 1, which is negative 6. Now we can just simplify that, so we're going to have 3x squared. X minus 18x is minus 17x. And minus 6. This is the answer to the question. That's the quadratic equation that has positive 6 and negative 1/3 as its solutions. And if you don't believe that, you can take either 6 or negative 1/3 and just plug them in right here. And when you solve that out, you'll get 0. Okay, so then in the first page we talked about 5 different types of factoring. The first type of factoring is what's called using the greatest common factor, and I'll abbreviate that GCF. So greatest common factor means what is the biggest number that goes into 16 and 8, and that would be 8. And then what's the biggest power of x that these both have in common, and the answer is x to the first. This one has 2 x's, that only has 1, because that's an x to the first, so they only have an x to the first in common. And then to factor this, we need to, well, we just pulled out an 8x. Pulling out or factoring out an 8x is like dividing both of those by 8x. So 16 divided by 8 is 2. X squared divided by x to the first is x. And then the second one right here, 8x divided by itself, is 1. And you can check, if you distribute this back, you'll wind up with what you started with. That's a good way to check. So now this says solve. This we haven't solved it yet, we've just factored it. So to solve this, we need it to equal 0, and there's 2 ways that this could equal 0. 2x plus 1 could equal 0, or 8x could equal 0. If either of those are 0, you're going to get something multiplied by 0, and that equals 0. So we'll solve this by dividing by 8, we get x equals 0. It's the only way that this thing right here could be 0. We'll solve this by subtracting 1, and then dividing by 2, and we get x equals negative 1/2. That's our second solution. And again, you could check either of those by plugging them back into this original equation right here, and you get 0 in both cases. Alright, let's take a look at this second one right here. So the greatest common factor, what's the biggest number that goes into 6 and 18? That would be 6. Biggest power of a they share in common would be a to the 4th. This, then we divide by 6a to the 4th. This thing divided by 6a to the 4th is just a to the 1st, or a. This thing divided by 6a to the 4th, 18 divided by 6 is 3. a to the 4th divided by itself is just 1, so we don't need to write anything there. And now again, there's 2 ways that this could equal 0. That's one way it could equal 0. Here's the other way it could equal 0. You divide this by 6, a to the 4th equals 0. The only number to the 4th power that equals 0 is 0 itself. So there's one solution. Over here we would subtract 3 from both sides, and there's our second solution. A equals negative 3. Okay, that was the first type of factoring. Second type of factoring is what's called factoring a trinomial, and that's a trinomial right there. trinomial tri means 3, so it has 3 terms, x squared, 16x, and 64. And so here's how we do this. We ask ourselves, what numbers multiply to 64 and add to 16? And you may not know off the top of your head. If you're not sure, what you can do is make a table and just list out the numbers that multiply to 64 and see what they add up to. So the first numbers are 1 times 64. 1 plus 64 is 65. That doesn't work. 2 times 32 multiplies to 64 but adds to 34. We don't want that. 3 doesn't go into 64. 4 times 16 equals 64. When we add 4 and 16, we get 20. 5 doesn't go into 64, neither does 6 or 7, but 8 does. 8 times 8 is 64. When we add 8 and 8, we do get 16. So that original problem factors to this, and this negative 8 is going to make this thing equal 0, that whole parentheses, and negative 8 will make this equal 0. So really you just have one solution, you just have negative 8. A little bit faster way to write this is x plus 8, and that whole thing is being squared. That's what this means right here. So that is factoring a trinomial. Okay, next type of factoring, factoring a difference of two squares. Now you might be able to just look at this and tell what the answers will be, but it's usually a good idea to put that in standard form, which is x squared minus 64 equaling 0. So even though this would be a strange way to write it, you could actually write this as x squared plus 0x minus 64. And now we're looking for numbers that multiply to negative 64 but add to 0. And if you think about it, the only numbers that multiply to a negative, one of them has to be positive, one of them has to be negative. Any other combination, a negative times a negative, or a positive times a positive, that's going to equal a positive number. But that's not a positive number, that's a negative. So we just said what numbers multiply to 64. If we go back a page, it's all of these right here. Well, if one is positive and one is negative, then we'd have to just alternate them. We'd have to list them out. So negative 1 times 64, negative 2 times 32, negative 4 times 16, negative 8 times 8. These ones right here add to 63. Negative 2 plus 32 adds to 30. Those two add to 12. The only ones that add to 0 are these last two. So the only way we could factor this is having x plus 8 times x minus 8. And then we could solve it by seeing what x value makes this parentheses 0, that's negative 8. What x value makes that whole parentheses equal 0 would be positive 8. So this, by the way, the name for this is called a difference of two squares. The reason it's called difference of two squares is this is a square, that's x times x. That's also a square, that's 8 times 8. And difference in math means minus. It means you're subtracting two things. So the difference of two squares, that's the pattern. I want to show you one more of those just to drive that point home. Let's say we had 9x squared minus 100. Okay, this is also a difference of squares. What did I square to get 9x squared? I squared 3x times 3x. What did I square to get 100? I had to do 10 times 10. And then how do I get there? There's no middle term here. Remember, for quadratic form, for standard form, there's usually a middle term, a bx term, but that's not here. Okay, so how does that happen? If you do plus and minus, when you FOIL this out, the middle terms cancel. So let's just prove that. The first terms would be 3x times 3x, which is right there. The outside terms is 3x times minus 10, which is minus 30x. The inside terms would be 10 times 3x, which is plus 30x, and that's exactly what we wanted to happen. We want those to cancel each other out, and they do. And then the last terms, 10 times negative 10, is minus 100. So if you look at this, it turns out to be what we started with right there. And that's called the difference of two squares. Okay, let's, we did a couple of those, so we'll skip that part. We'll do maybe the second one right here. So we want numbers that multiply to negative 162, and we want numbers that add to 21. Again, because this is negative, one will be positive, one will be negative. It's kind of hard to tell off the top of your head what multiplies to 162, so let's make a table right here. And we want them to add to 21. Okay, so we'll have negative 1 times 162, that doesn't add to 21. And to get these numbers, by the way, I'm just going in order. There's 1, there's 2, the next one I'll try is 3. That way you can make sure that you hit every single possibility. So negative 3 times, I think, 54 adds to multiplies 162 doesn't add to 21, though it adds to 51. 4 doesn't go into that, 5 doesn't go into it, 6 goes into it. Negative 6 times 27 is negative 162. And if you add those, you do get 21, and that's what we wanted. So it should be x minus 6, which goes here, x plus 27, which goes here. How do we make this one equal to 0? Well, that would be negative 27. How do we make this one 0? That would be x equals 6, and we're done. Alright. Next one, how do you solve this? So notice that the original coefficient right here, this is not 1. Okay, so we can't do y times y, because if you put a y right here and right here, it's not going to multiply back to 6y squared. So there's a couple ways to do this. I'm going to show you what I think is the easiest. It's called the swing method. The swing method means that you take this 6 and you swing it, or multiply it over here. So because I swung the 6 over, it's not there anymore. And 6 times 20 is 120. So now this problem that I just wrote is something that we know how to factor. We've done a bunch of those before. So we want numbers that multiply to positive 120. That means they both have to be positive. And add to negative 23. If you made your table, if you made your chart, and you went down the list looking for these numbers, okay, these are the things that multiply to 120. None of these work right here. If you add them all together, none of them end up working until you get to, let me just fill this in real quick, until you get down to 5 doesn't work either, 6 doesn't work, okay, those add to 19, 6 times 20, when you add those you get 14. It finally works when you get down to 8. Okay. Oh, I'm sorry, there's actually a mistake right here. This is adding to a positive, but it's multiplying a positive, adding to a negative, so that means they should actually both wind up being negative numbers. A negative times a negative is a positive, but a negative plus a negative is a negative. So these all need to be negative here. That's a negative 15. That's negative 26. That's negative 29. Negative 34. Negative 43. Negative 62. Again, the reason that these all have to be negatives is because we're multiplying to a positive but adding to a negative. The only numbers that do that are two negative numbers. So we just found minus 8 and minus 15 as our result. Okay, now here's the thing. We don't, again, if we multiply y times y, that's not going to take us back to 6y squared. So here's what we need to ask ourselves. That 6 that we started with, where is it right now? It went into the 120. That means it's still in the 8 and the 15. How did you get the 6 there? You got it there by multiplying. So you get it out by doing the opposite. You're getting out by dividing. So then let's reduce these two fractions. 8 over 6 becomes 4 over 3. 15 over 6, well, 3 goes into that number 5 times, and 3 goes into that number twice. And here's the thing, it's called the swing method because now that we have these numbers here, once again, if we do y times y, we're still not going to get 6y squared. It's called the swing method because you take these denominators and you literally swing them in front of the y. So when we swing the 3 in front of the y right there, we get 3y minus 4. And when we swing the 2 in front of the y, we get 2y minus 5. This is now completely factored. You can test it. 3y times 2y, that does equal 6y squared. And if you FOIL out the rest of it, you get what you started with. Okay, this is supposed to be solved by factoring, so we haven't solved it yet. If you solve this, if you set this equal to 0, and solve it, you would add 4 to both sides, and you get 3y equals 4, divide by 3, you get y equals 4/3, and notice y equals 4/3, you actually could have got that in this right here. 4/3 is what makes that 0. And for the same reason, if you solve this one right here, by adding 5 to both sides, and then dividing by 2, you get y equals 5 over 2, and you actually could have gotten that from this parentheses right here. So that's how you use the swing method. One thing I want to point out is for a problem like this right here, let me just divide this off, it's getting kind of messy. This would be terrible if you tried to swing the 15 over, that would be a huge number. What you should do first is look at these numbers and see if there's a common factor, and there is. The number 3 goes into all of those, so 15x squared divided by 3 is 5x squared. Negative 84 divided by 3 is negative 28. Negative 36 divided by 3 is negative 12. Now you would use the swing method on what we did right inside. And that 3 is still going to remain there the whole time. It doesn't affect your answer, but the 3 needs to be there so that when you multiply it out, you get back to 15x squared. And you solve that the same as we solved that other one. Last type of factoring is something called factor by grouping. So let's take a look at 125. Grouping means that you group, if there's 4 terms, you put them in groups of 2. So we'll start with this one. And we want to know what's the greatest common factor of 10 and 8. That would be 2. What variables do they have in common? They both have an a, but that's all they have in common is an a. So we're going to divide both of these by 2a. 10 divided by 2, that gives us 5. And ac squared divided by a, those cancel. You just left with c squared. 8af over 2a, the a's again cancel. 8 divided by 2 is 4. And by the way, that's a minus right there because that's a minus right there, this minus. And the f is still there. So if we do this correctly, this 5c squared minus 4f, that should be what shows up in this other parentheses when we factor this by grouping. So that's a plus right there, so I'm going to put a plus there. What's the common factor of 40 and 32? Well, 8 goes into both of those. What variables do they have in common? They both have an x in common, so I'm going to pull out an 8x. If you divide this thing by 8x, 40 divided by 8 is 5. X is canceled and you're left with c squared. And then this thing divided by 8x would be 4f. And again, there's a minus 4f because that's a minus right there. So now we'll look at what we have, and the question is, what do these two things have in common? Well, they both have a 5c squared minus 4f in common. So we're going to pull that out in front because that is their common factor. They both have a 5c squared minus 4f. What's left over here? Well, I'm going to pull 2a plus 8x. I'm going to pull that into its own parentheses. And that's it right there. That's the factored version. You can test that by foiling that out. That would be kind of a mess, but if you do foil it out, you'd wind up back where we started at the beginning of 125. So that's factoring. Factoring is just it's kind of the reverse of multiplying. We talked about the greatest common factor, talked about trinomials, the swing method, and difference of squares, and then this last one, which is factor by grouping. So hopefully that made sense.